We are continuing on in OLI Mod 25. This goes along with an example in OLI on page 166 regarding drinking and driving. I'd like you to go ahead, take a minute, pause the video, read through the whole setup, and then come back. Okay, hopefully you've taken a moment to read through. We're going to start with considering our null and our alternative hypothesis, really just in the context of what we're trying to find out here. So we're looking at a relationship between reaction time and drinking. In particular, though, okay, they're using a random sample to examine the effect of drinking 2 beers and then looking at the reaction times. So because that's the way that they're performing this experiment, that really is the way that we're going to write our null and our alternative hypotheses. So our null hypothesis, in just a word sentence, is going to be that drinking 2 beers will not change reaction time. That is our baseline value of no change, is that the reaction times will be the same. And then for our alternate hypothesis, if drinking the 2 beers is going to have an effect that would increase our reaction time. So I'm going to take a moment here and write out each of those hypothesis statements. Okay, so I have those sentences written out for us, and let's think about the data that we're going to consider here. So in our sample of size 20, here is our before data and here is our after data. But in thinking about what we're looking at here, our concern is how that reaction time has changed individual by individual. We wouldn't just want to take a look at the mean of all these and compare it to the mean of all the afters, because we would miss whether things are increasing or decreasing. If we just look here, person number 2, their after time is much less than person number 1's before time. So it's very important that we match up each pair of data and keep those pairs together. And so the way we've done this to keep these matched pairs together is to create a new data set. And the new data set is the difference in those reaction time. And we're subtracting in this order: the before time minus the after time. So notice that if the before time is smaller and then that after reaction time has increased and it is bigger, then what we're going to end up with is a negative number here in our data set. So every time we see a negative number, that's telling us the amount by which the reaction time increased. For a few folks, like here, that after time actually decreased the reaction. So that's why this ended up with a positive number. So once we put all of our data together, this single column of differences becomes our sample data and is representing the population data that we're trying to make conclusions about. So even though we have 2 populations to begin with, the population of before times, the population of after times, what we're really concerned with is the single population of the differences in those times. So this becomes our single data set, and we proceed just like we would with a hypothesis test of any single population. So honestly, the first thing we notice here is that our sample size is 20, which is less than the required value of 30. So what we need to do is check out that our sample data, these 20 differences in reaction times, don't have a highly skewed distribution and don't have outliers. So I've put this data over in StatCrunch over here, and if you were going to do this on a test, then I would have this as a data set that you could download in StatCrunch, and you wouldn't need to put it in yourself. But that's what I did here. Just put this data in, and now I'm going to make a histogram using that. Let me just try and make that a little smaller for you. Using that before, minus, after data, we compute, and we see that our conditions are okay. This is not highly skewed one way or the other. I know it's a little bit skewed to the right, but it's not highly skewed, and there are no outliers. So we are going to go ahead and proceed, and we'll talk about this criteria a little more in step 2, where it comes in our hypothesis test. But really, you would always want to check for that first, just to make sure you should even proceed and you don't waste your time if you shouldn't. Okay, so let's just go ahead and proceed here then. We need to get our null and our alternate hypothesis written with some symbols. So what is going to be the case if there's no effect on reaction time at all? Well, if the befores and the afters were exactly the same, if there was absolutely no effect, then our mean of these differences, mu, would be equal 0, because the befores and the afters would be exactly the same. For our alternate, if drinking 2 beers will increase reaction time, we need to be careful here. Increase in reaction time means that these differences have a smaller number minus a bigger number, which then produces a negative number. So our alternate hypothesis is actually that mu would be less than 0. All right, on to step 2, where we need to give our sample values, the sample mean and the sample standard deviation. So again, we have a column of data here in StatCrunch. If you recall, to get our mean and standard deviation, we go to Stat, Summary Stats, by column. That's my column. I want just the mean and just the mean, and standard deviation. There we go. So those are the values that we need. So over here, let's see, my sample mean x bar is negative 0.4615, and my sample standard deviation S is 0.8692. Let's round off to 4 decimal places there as well. So that is our sample values. Next is that we need a random sample, and we are told up here that we have a random sample. So that is given. We're good to go there. Okay, and now is the requirement about our sample size. So I'm going to write that n equals 20, but histogram of my sample data isn't highly skewed. And shows no outliers. So we are good to proceed, but perhaps we'll put that in our final conclusion. Okay, on to step 3. Okay, I've just given myself a little extra room here. All right, so our sampling distribution, okay, is the distribution of all our kind of before, minus, after times. Those are our X bar values. It's the before, minus, afters. We've decided that we can go ahead and use this T distribution with a little caution because we know we've got that small sample size there. The center, we believe HO, and HO tells us that the mean will be 0. And then our sample value of negative 0.4615 is off to the left. Okay, now we need to let everybody know that our p-value is the probability about our x bar value. It's to the left, so it's going to be the probability that x bar is less than or equal to that value we got, 0.4615, under the condition that mu is equal to 0. We're going to go into StatCrunch. We're going to use the t-stats function, get our p-value and our test statistics. So over to the side here, t-stats, we are picking one sample. I know there were 2 populations and 2 samples to begin with, but because they were matched pairs, we combined them. There's only one sample of data that we're using, this sample of data that's here. Now, actually, we've always been picking with summary for this. Let me see if I can just get that screen to go out to the right. T-stats, no, it's just going to come left. Okay. So I'm going to do both. I'm going to go ahead and pick with summary. We can put in our sample mean of negative 0.4615. Our standard deviation was 8692. Our sample size was 20. Our null hypothesis, this was a less than, yes, and compute. So here is our p-value and our test statistic. So this p-value is coming out 0.014. So under the condition that there is no difference in reaction times, we have gotten sample results that would occur about 1.4% of the time. So this is below our general 5% threshold. This is telling us that we have an unusual and unlikely occurrence. This is going to make us then want to reject our null hypothesis and support our alternate hypothesis, HA. And further confirmation of that is that our test statistic, negative 2.37, has us really very far from center, right? More than 2 standard deviations off to the left. So again, this far from center goes along with a very tiny p-value, causing us to reject our null hypothesis and support our alternate. Just to go back to StatCrunch for a minute, since we do have that data in our data table here, right? We haven't had this before, but here's the data right in my spreadsheet. So I could pick with data, pick my column, set up my hypothesis test, click compute from there. And as you can see, we get exactly the same results that we had before. So just different options. You can use whichever one you like. All right. I would once again, like everybody, encourage everybody to pause this video and see if you can write your final if, then, therefore conclusion, and then come back and see if we agree. Pause it now. All right, take a look at what I have, see if it is the same as what you came up with. If drinking 2 beers has no effect on reaction time, because that was our null hypothesis, then our sample results are unlikely. We know that because our test statistic shows we're far from center, and we have a very small p-value, a very small probability of our sample results happening. Therefore, our data supports our alternate hypothesis that drinking 2 beers increases reaction time. And I did include a note that our hypothesis test was conducted using a small sample whose distribution wasn't highly skewed and showed no outliers.